Welcome, learners. My name once again is Mr. Paul Chilola, your teacher on this platform. Welcome, both new and old students. Here at Black Slides, we take so much pride in you, our students. Our main goal is to educate the Malawian children, the Malawian students, to give them science education in physics, chemistry, and biology, and mathematics. So once again, our target is to produce as many distinctions as possible in the sciences at MSCE. All right, so if you are watching from a YouTube channel and you have not subscribed to the channel, consider doing so, because this will help you to be notified every time we have a new video lesson. You are given a notification is sent to you to notify you that a new video lesson has been uploaded. If also you are learning on the main Black Slides online secondary school platform, make the best of your learning there by completing all the homeworks, downloading the notes that are posted there, and doing all the activities assigned to you. Once again, in case you would like to get in touch with me, your teacher, don't hesitate to simply send me a text message on the numbers shared here. I'll be very quick to respond to you and accord you the support that you ask for. Once again, you are welcome. We continue looking at the topic called radioactivity. So far, we've looked at the definition of the key concepts which are very crucial to the understanding of this topic. Namely, we've looked at the definition of radioactivity, nuclear decay, and other related topics, concepts. We've also looked at the properties of three types of radiations, such as alpha, beta, and gamma, and their differences as well. We've also looked at the nuclear decay equations, and by now you should be able to write nuclear equations when enough information is given. All right, so today, in today's lesson, we are going to continue looking at the topic now with respect to what is called the detection methods. How can you detect alpha, beta, and gamma radiations? So we are going to dwell on this in today's lesson. All right, pay attention. Let me ask you to pay attention, the best of your attention, allowing no distractions to draw you away from concentrating on the lesson, because it is in the lessons that we explain key concepts and processes in preparing for MSCE examinations. I want you to come back with a testimony when you get your distinctions in physics, chemistry, and mathematics, as well as biology. I want you to come back to Black Slides and testify. Welcome one more time. All right, so by the end of this topic, all right, we are going to, look at your ability to define radioactivity which we already have done. All right. So we are saying by the end of this lesson, students should be able to define radioactivity and explain why detection is important. All right, detection. Describe the principles of common radioactivity. Describe the principles of common radiation detectors. So for each method of detection, there is an underlying principle. And your examiners would love you to be able to explain the principle behind each radiation detection method. And then you should be able to compare different detection methods and their applications. Then you'll be required to solve exam-style questions on radioactivity detection. These are the objectives. So we are going to dwell on these objectives. By the end of this topic, you should be able to tackle these key skills. All right. So a little bit of introduction, which might be vital to the understanding of this topic and lesson. Radioactivity we defined before. Radioactivity is the spontaneous emission of particles, alpha or beta, or electromagnetic waves such as gamma rays from unstable nuclei. That's okay to define radioactivity like this. So we are saying radioactivity is the spontaneous. Last time I explained the meaning of spontaneous. Spontaneous simply means the process takes place naturally without having to cause it. Of course, you will also learn in future that there is what is called induced radioactivity. But now we are looking at the process occurring naturally, whereby particles alpha and beta, as well as gamma rays, are emitted from unstable nuclei. All right, so since radiation is invisible, you cannot see radiation, and it also is odorless, meaning it has no smell. Therefore, we need special detectors to measure and study it. All right, we are saying that these radiations, the particles alpha, beta, and radiation gamma rays, are not visible. You can't see them. You cannot smell them. Therefore, we need to find a mechanism to detect them, to tell their presence. Okay. Very, very important. So the main detection methods, we are going to start off with a method known as photographic film. So we can detect radiation using a photographic film. This is one we would like to discuss now. In future, we are going to look at others. All right, so the principle behind the working of the photographic film is that when a photographic film is exposed to radiation, the radiation is going to leave dark spots. It's going to darken the photographic film. All right, we shall see how this happens. And this is applied in film badges, which are worn by workers in the nuclear plant to monitor exposure. All right. All right, so what happens is this. Okay. So we have a source of radiation. So the three forms of radiation, alpha, beta, and gamma, are emitted from the source, in front of which there is an object. Remember that Some radiations can be blocked by certain objects, others can pass through objects. So that which passes through the object is going to fall on the photographic film. This is the photographic film. Initially, the photographic film is not dark, but upon being exposed to radiation, it is going to change its color to black. It is going to be darkened. So the darkening signifies the presence of radiation, which can be alpha, beta, or gamma, depending on which one has been allowed to pass through. Right, so this is just a diagram to illustrate the working of the photographic film to detect the radiation, the presence of radiation. So how does it work? So the first stage is the radiation exposure. Nuclear radiation, especially gamma rays, penetrate the protective casing and strikes the film. So this works best with the gamma, with detection of gamma. All right, so the gamma rays are going to strike the film. Once they strike the film, the next stage is ionization effect. So the radiation is going to ionize the silver halide crystals. So on the film, all right, on the film there is silver halide. Silver halide is simply Ag. Silver halide is the Ag. It can be a silver atom, Ag, combined with bromine, or it can be silver and iodine, or silver with any group 7 element. All right, remember that halides are the compounds of the group 7 elements. Right, so the second stage, which is ionization effect, radiation ionizes. To ionize means to turn the silver halide into ions, and this brings about a chemical reaction. Then the third stage is called the development process. So the film is chemically developed. Areas which are hit by radiation turn black or dark, while the unexposed areas remain light or colorless. So the interpretation is made. The degree of darkening shows the amount of radiation received. This also is used to monitor exposure levels. Alright, so this is a detection of radiation using a photographic film. Alright, thank you very much. My name once again is Mr. Pochilola. When we meet again, we are going to look at the other detection methods. Once again, welcome to the platform. If you are new to the channel, consider subscribing to the channel so that every time I upload a new video lesson, you become the first one to be notified. Once again, bye-bye for now.